All right, this is for 51 through 58. All right, 51 to 58. Okay, this is how it works. We're doing circle stuff now. So this is force centripetal, this is tangential speed, this is period frequency, and this is also Newton's law of universal gravitation, that big GMM over r squared. All right, so let's take a look at the first one I'm going to do. We're going to do 52. So 52 says he found big G by having a couple of masses. So let's see. M1, 7.5. M2, 0.075. And their centers, so that's the radius or distance, is 0.054 meters. Kilograms, kilograms. All right, all your stuff has to be in kilograms and meters. All right, let's see. What's the question asking? Find the force of attraction between them. And they give you the gravitational constant there. All right, so my unknown, these are my givens. My unknown is force equals. Okay, so let's look for an equation that has all these things right here. Okay, so we need to have an equation that has all these things, otherwise I can't use it. Okay, this is physics 101 here, right? Hopefully. Okay, so let's see. Okay, here's a force equation. Why can't I use this one? Because I only have one mass in this one. And acceleration isn't given in this problem, so I can't use it even though force is in it. How about with a work equation? No, because there was no work given. There was a distance given, but that's not going to help us. Okay, we're not going to use the torque equation because there's no torque. All right, does it make sense like how we're doing this? You really shouldn't be confused on this part. You need to pick equations that make sense. Okay, look, here we go. Let's look here. Can we use force electric? No, because I wasn't given any of these values for Q, right? Here we go. How about this one? Big G, which I do have. M1, M2, and distance were all given. Hey, look at that. I can solve for force like that. Not hard, right? Okay. So let's go ahead and do that then. All right. So you need to write this step on your paper. Force gravitational equals big G, M1, M2 over distance, or r squared. Okay, now you plug in. You got to plug in the numbers, okay? Plug in the numbers the same way that they're here. Is a parentheses out here. Big, so double parenthesis, the numerator. Mass of first object times mass of second object, close the double parenthesis. And then the distance has to be squared, or otherwise this doesn't work. And you should get your answer that way. Okay. All right, next one. Let's look at 53. The force gravitational between. So as soon as I say force, you know that that's your F is given. It's 3.83 times 10 to the negative 8th. How do I rewrite this right here? It's that capital E, right? E negative 8. Okay, that's how you would write that. If one student has a mass of, so that's mass 1, 58.1 kilograms, and the other has a mass of 63, so that's mass 2. How far apart are the students sitting? All right, so remember that the other one is your big G is given. 6 point, you plug this in every time, and you should have this on your formula chart. Instead of times 10 to the negative 11, E negative 11. Okay, so that's what you're going to plug in every time you use G. All right, now what's the equation? So put your equation. Force gravitational equals big G times M1, M2 over distance squared. Okay, how do I solve for distance? Remember, we have a top and a bottom. You switch them. And then what do you do to the square? You got to square root both sides, right? Okay, so you plug those in, you'll get your answer. Alrighty. Okay, next one. Okay, so you should know circles and strings and all that stuff. Force always points where? Okay, if you're not sure, ask your neighbor. And which way is it going to go? So if I'm going clockwise or counterclockwise like this, and I break it right here, what was the direction of my velocity at this point right here? So watch my red point. it was going boom that way, so look at where it's going to break. You should always answer that question that way. All right, next. All right, let's see here. All right, I'm going on to 57. Calculate the period of a ball tied to a string. You need to write this on your formula chart because the period is not on your formula chart. Okay, so if you look here, you notice that you have centripetal acceleration, which you could plug into force centripetal, right? You could figure out force centripetal if you plug in centripetal acceleration here, but you're not given a way to figure out tangential velocity. All right, so you need to write this on your formula chart in this line right here so you have it for the test, okay, right here. Okay, here are the equations you need. So period and frequency are inversely related, right? So here's the equation for frequency, the cycles per time period, or cycles per second. And remember that period is the inverse, right? Period, big T, is time over the cycles. In the calculator, you hit that x to the -1 button to be able to get either one of these. If you have the frequency given, then you would just hit x to the -1 to flip it. All right, so let's see. So in this problem, in 57, what are our givens? So the length of the string. So the length of the string in this case, if a string is spinning in a circle, the length of the string is acting as the radius, right? All right, so that's the r. And remember that, so our given is r of 1.21, making 3 revolutions per every second. So let's see, revolutions per second, that's what, frequency or period? That's a frequency. 3.6 revolutions per second, that's like cycles per time, right? So that's revolutions per second. So guess what? Cycles and revolutions and time and seconds mean the same thing, so that makes this a frequency, right? Okay, so I actually don't need that, right? I really don't need the radius to be able to do this problem, right? Because what is my equation that I use for this? Frequency and period are inversely related, right? So I would take this and put in the calculator, 3.6 x to the -1. 3.6, yep, and it'll give you the answer. Okay, cool. Okay, so those are super simple. Okay, now, let me see. There is an equation now that I'm going to give you. So you can get the tangential velocity or the centripetal velocity or the linear speed. Okay, so all those are ways that it can be asked. Remember that velocity is always distance over time. But what's the distance around a circle called? It's called circumference, so that's 2 pi r circumference. And what's the time? We're not going to use a time that goes up and up and up and up and up and up forever, but we're going to use a period, so the time it takes to repeat a cycle. Okay, so remember, these are the equations that you need to put next to your formula chart, so that way you have them. All right, so let's look at the next question. Calculate the speed of the ball. All right, so that would have been a 2-parter, so you need to make sure you have that answer. All right, so 0.277778 was my period from the previous one. I got that from there because that's what I would have gotten had I done the inverse of the frequency. By the way, do not round anything until the very end. Do not round anything until the end. Otherwise, it's going to come out wrong. And remember, we're rounding out to 3 decimals. Some people have said they've gotten it right with less, but I'd say just do 3 because how can you go wrong? Okay, so in the previous problem, what was my radius? What was the other given that I had? My radius was 1.2 meters. So let's look at this equation. Let's look at the velocity centripetal equation. Do I have radius? Yeah. Do I have period? Good. So I can figure that out. Okay, so you just plug that in, you'll get the answer. All right. Oh, don't want to undo that. Okay, let's see. All right, and that looks like it's about it. That looks like it's about it for this one. All right, good luck. The last ones we got left are impulse momentum, so that's what we'll do in the next one.